I want to
Real
teach
current.
that.
Yes, real current source. Real current source. So what is ideal current source? What is ideal current source? I have explained what is ideal current source.
Ma'am, it is a
Ready?
constant current source which
Is a
supply the
constant.
same current to any resistance connected across its terminal.
Yes, very good. So when you are connecting a resistance across the current source, then whatever the current source is giving, suppose this is I ampere, let it is 10 ampere. So that amount of current should flow in a resistance which is connected across the terminals of the current source. Okay. So that means there is no other path that the current is flowing. Okay, because this will happen only when this internal resistance is infinite. R is what? R here I am taking it as the internal resistance. If the internal resistance is infinite, then I can tell that this is an ideal which source? Current source. Am I clear to you? Surachita, am I clear to you? Surachita,
Yes, ma'am.
you are clear? Am I clear to you?
Yes, ma'am.
Okay. So real current source is what? Shubham, Das, what is real current source? Shubham,
Yes, ma'am.
what is real current source?
In this, ma'am, internal resistance of the current source is very high.
Very good. So this is very, very high. So this is the symbol of the real current source or practical current source. Real or it is practical current source. Ritankar, am I clear to you? Ritankar?
Yes, ma'am.
Okay. So now next come to, we will go to Kirchhoff's law. Kirchhoff's law. Who can state Kirchhoff's law? Abhijit Anand state. Abhijit Anand.
Yes, ma'am.
54. Tell what is Kirchhoff's
Ma'am,
law?
Kirchhoff law.
But how many laws are there?
Ma-
Two laws are there?
Yes, ma'am.
Okay. So state the first law. Two laws are
Ma'am,
there.
first law is the sum of current flowing from a junction is equal to the sum of current flowing toward it.
Okay. Your law should be, I have told you, when you are telling the law, that means you are stating the statement of the law.
Ma'am, Kirchhoff current law.
Yes, this is Kirchhoff's current law. We call it as, in short, this is, mute yourself. Good, Abhijit. Kirchhoff's current law. So the statement of the law is, the statement is here. I will write down the statement. Ananya, you will tell me whether the law is correct or not. The Ananya Singh, the algebraic sum of currents flowing, algebraic sum of currents flowing towards a junction, in an electric circuit. In an electric circuit is zero. Is zero. Is it correct, Ananya? Ananya is absent. Ananya Chaudhary?
Yes, ma'am.
Yes, tell. Is it correct? Just tell me
Yes,
whether it
ma'am.
is.
Yes, ma'am.
Anika Singh, is it is correct?
Yes, ma'am. I think so.
Correct.
It's good.
Okay. So, Sasank, Deepak, is the statement correct?
Yes, ma'am.
Okay, very good. So, algebraic sum of current flowing towards a junction is equal to zero. Okay, so now here you tell me, suppose there are different currents flowing here. Okay, so let this is I1, this is I2, this is I3, this is I4, this is I5, this is I6. So what are the currents flowing towards the junction? If I1 is I6, suppose you are taking this as I6, what is the current flowing to inside the junction? Yeah, where I have taken a junction A. So what is the current flowing towards the junction? It is minus of I6. Right?
I6.
So here the current I3 is flowing outward. So what is the current flowing towards the
Minus
junction?
of
It is
I3.
minus of
Minus
I3.
I3.
So I can write down the sum of the currents flowing towards the junction as I1 plus I2 plus minus of I3 plus I4
Minus of
plus I5 plus minus of
minus
I6.
of I6.
0. Okay, so the sum of the currents flowing, that means here I can also write I1 plus I2 plus I4 plus I5 is equal to I3 plus I6. Am I correct or not? So these are
Yes,
the
ma'am.
incoming currents. So incoming currents will be equal to the
Outgoing current.
incoming currents are equal to the outgoing current. Clear to all of you? Sasi, am I clear? Sasi Prakash, Somendra Das.
Yes,
Clear?
ma'am. Shashi Prakash.
Soham, got it?
Yes, ma'am.
Soham Patra. Very good. Now come to the second law. Kirchhoff's voltage law. That is the second law, Kirchhoff's voltage law. Who will
Yes,
tell
ma'am.
me the statement of Kirchhoff's voltage law? Tell me.
Sum of all the voltage drop around the loop is zero.
Okay, so you have to take into consideration a closed path or a closed circuit. In any closed circuit, the algebraic sum, here you see we are discussing about DC circuits. That's why we are telling the algebraic sum, but it will be different. Same law will be applicable. Suppose I will ask you a question, still I have not taught you. Can these two laws be applicable to AC circuit? Because AC you have read in your 12th standard, somewhat you have read. Is it applicable to AC circuit or it is only applicable to DC circuit? Tell me. Yes or no, tell. No answer. Can this law be applied?
Ma'am, I think ma'am, it is applicable on both AC also.
मैम लेकिन जो डीसी के वोल्टेज होगा वो तो कंसिस्टेंटली वो चेंज करता रहता है ना पोलैरिटी, तो फिर कैसे कह सकेंगे हम?
एसी में नहीं होना चाहिए.
इसमें नहीं होना चाहिए.
AC में होता है मैम, KCL सॉल्व किए हैं AC लेकर.
AC also, I will tell you. I will tell you when I will teach you AC circuit. Remember that Kirchhoff's voltage law and Kirchhoff's current law are applicable to both AC circuit as well as DC circuit.
Yes.
Okay. I will tell you when I will teach you the AC circuit, not now. Okay. But both are applicable. Both the laws are applicable to both the circuits, AC circuit as well as DC circuit. Okay. So let me tell you here, so the Kirchhoff's voltage law, any closed circuit, the algebraic sum of all the currents, EMF, electromotive force, EMF and voltage drop is equal to 0. So here, why you will think so much? Here I have told you this is algebraic sum. When you are considering the DC circuit, this algebraic term will be replaced by a term phasor or vector. Understood? Both the laws will be applicable, but in case of an AC circuit, instead of you taking the algebraic sum, you will take the vector sum. Am I clear? Suppose somebody will ask you whether Kirchhoff's voltage law or Kirchhoff's current law is applicable to AC circuit. You are reading in DC circuit. Yes, it is applicable to AC circuit, but instead of taking the algebraic sum, there we are taking the phasor sum. Am I clear to all of you? Okay.
Yes, ma'am.
You will read. I will teach you when I will teach the AC circuit. There I will tell you everything. Don't worry. So now it is clear. Now, so let us take a simple circuit. I will take a simple circuit where I am having a number of EMFs, batteries, and resistors. Okay. Arbitrarily, I have taken some EMF and batteries. So you tell me, using the Kirchhoff's voltage law, write down, tell me the equation. This is E4, this one is R1, this is R2, this one is R3, this one is R4. Now let the inside the closed circuit, remember that Kirchhoff's voltage law you can apply only to closed circuit. You cannot apply it to an open circuit. So this is the current, suppose. So what will be the equation? Tell me, what is the equation? Using Kirchhoff's voltage law, tell me the equation. Dipanjan, are you there? Dipanjan,
Yes, ma'am.
Aryan Prasad,
Ma'am, summation of I
Yes,
into
sir, I am there.
I into R2, I into I3, I into R4.
yes, any other? Anyone can tell me? Summation of IR plus
E1 plus E2 plus IR2 plus IR3 minus E3 minus E4 plus IR4 plus IR1 equals to 0.
according to the Kirchhoff's voltage law, this
Yes,
is
ma'am.
correct. This is correct.
Yes,
Yes or no?
Yes.
Okay.
Yes, ma'am.
What is the summation of EMFs and summation of the IR? If I will start from this point, if I will start from this point, let this is A, I will move because I have to apply this law in a closed circuit, right? So this will be minus I into R1, then it is, you are taking plus or minus?
Minus.
Minus.
Minus C1,
Minus.
minus 2,
Minus.
minus I into R2, minus
Plus.
I into R3,
Plus
plus
E3
plus E4
E4.
plus E4,
E4.
minus I into R4.
minus R4
Only zero.
Okay. So this is my Kirchhoff's voltage law equation, which you have already read in your 12th standard, right? Any confusion with this equation? Tell me.
No, ma'am.
No, ma'am.
Any confusion? Okay. So here you have not asked me one question. I was expecting a question from you.
Ma'am, the positive and negative sign, ma'am. How to do that?
Okay. So here you have approached the question which I was expecting. You have approached that question.
Ma'am, if we
here
go from plus to minus, minus E,
Yes, ma'am.
minus to plus.
I will tell everything. I will tell you. Don't worry. But I was expecting a question from you. Here I have you see I have written here voltage drop here. Nobody, that means there is a term of voltage rise. If I am mentioning a voltage drop term here, then there is some voltage rise. There is, yes or no?
Yes, ma'am.
Yes,
So
ma'am.
what is that voltage rise? You have not asked me, so I am asking you. You tell me what is voltage rise, and when you tell that there is a voltage rise in the voltage.
हम जब एक बैटरी अगर कनेक्शन में लगा हुआ है और एक और बैटरी उसमें ऐड कर दिया जाए तो वोल्टेज टोटल जो वोल्टेज होता है वो बढ़
क्यों?
जाता है।
यहाँ पर तो ऐड की हूँ, यहाँ पर सब बैटरी में ऐड की हूँ, सब सीरीज में कनेक्टेड है, सब ऐड की हूँ.
Ma'am, if short circuit happens,
नहीं वो
शॉर्ट
नहीं,
सर्किट हैपन.
E2 से
हम जैसे R1 से R2 में E1 और E2 के कारण वोल्टेज राइज होगा क्योंकि दोनों एक ही डायरेक्शन में है। ऐसा
No, I am not satisfied with your answer.
मैम दो डिफरेंट वोल्टेज का जो डिफरेंस होता है उसको शायद वोल्टेज की वजह से वोल्टेज राइज होता है.
तो voltage difference. No, I will.
उल्टा लिए थे.
Why you didn't ask me the question then? If I have written and why you would have asked me, madam, why you have written voltage drop? Why you have written drop? Why you
मैम
didn't ask
वोल्टेज
me?
राइज मैम समझ रहे हैं मैम मैम ऐसा जैसे करंट अगर लेफ्ट टू राइट जा रहा है और लेफ्ट साइड में बैटरी का नेगेटिव पोल है और
Okay,
राइट साइड
okay,
में पॉजिटिव पोल है
yes,
तो
yes. You know
voltage बढ़ रहा है.
approach. You know the answer. I am telling you. The sign convention, which is very important throughout the DC circuit, while analyzing or while solving a DC circuit, you should know the sign convention. Okay, this is the convention you have to take. You have to solve all the DC circuit by taking this sign convention. Okay, so this is very important. Listen the sign convention properly. So while analyzing a DC circuit, remember that in that DC circuit there will be the voltage source or the EMF or the battery, what you are calling. Another one is there will be resistors. We are not using inductors and capacitors while using a supply, DC supply, while using DC supply. Inductors and capacitors, why you are not using, you will tell me the later on. Okay, because inductors and capacitors will not work when DC supply is given to them. That is a question that we will be discussing when I will discuss the AC circuit, not now. So while solving DC circuit in this module which you will be reading, you will be coming across, while solving a DC circuit, you will be coming across the batteries or the EMF which I have shown you here and the resistors. Okay, so when you will take, how will you take the sign convention? Okay, suppose I am, so while traveling in a circuit, while taking the equations Kirchhoff's voltage law, while traveling in a battery, if you are traveling or the motion is in the same direction as the direction of the current, if you are traveling in the same direction as that of the current, then you will take as a drop in potential or drop in voltage, and you will take it as minus IR drop. Am I clear to all of you?
Yes, ma'am.
Drop in voltage you will
Yes,
take,
ma'am.
when you will take, when the motion is in the same direction as that of the current. Suppose you are traveling opposite to the direction of the current. You are traveling opposite to the direction of the current, then there is a rise in potential or rise in voltage, and you have to take plus IR. Am I clear to all of you?
Yes, ma'am.
Am I clear
Yes,
to
ma'am.
all of you? Yes. I am asking to each one of you. Okay. Anybody having any doubt, you are free to unmute and ask me a number of times. But your concept should be clear so that you can do problems later on. Otherwise, there will be you, because this is a programmatic paper, you will get number of problems in this module. Okay. Now come to the battery. Come to the battery. Here you know this is a higher potential, this is lower potential. When you are traveling or when the motion is from higher potential to lower potential, irrespective of the direction of the current, I don't have any interest in knowing the direction of the current. Whichever the direction, current direction is there, whatever that may be the direction of the current. But if you are traveling from higher potential to lower potential, then you will take that as drop in potential or drop in voltage. And if the battery is having the voltage E, then you have to take minus E, irrespective of the direction of the current, whether the direction is going from the left to right or right to left. I don't have any interest. Got it? Got it?
Ma'am.
Ma'am, can you
Okay.
repeat this again?
Ma'am, can you repeat this again?
If you are traveling, I am telling you, if you are traveling from higher potential to lower potential in a battery, if your motion is from higher potential of the battery to lower potential of the battery, irrespective of the direction of the current, okay, then you have to take, that means when a battery is there, you should need not to see in which direction the current is flowing in that branch. Okay, if you are traveling from higher potential to lower potential of the battery, then you will take that there is a drop in potential. Am I clear now? Who was asking?
Yes, ma'am.
Okay.
Yes, ma'am.
So now
मैम इसका एक उल्टा वाला भी तो है ना, जैसे
उल्टा
पॉजिटिव
वाला
टू
कर रही हूँ, उल्टा वाला कर रही हूँ, इधर ही उल्टा वाला करूंगी सेकेंड ये इसमें. So here, if you are traveling from lower potential to higher potential, if your motion is from lower to higher potential, your motion is in this direction, then there is a what? Rise in potential. And what you have to take? You will take plus E. Am I clear now? Where you will take rise in potential and where you will take drop in
Ma'am,
potential.
rise in voltage or rise in potential?
Rise in potential, rise in voltage, same. Rise
Okay.
in potential, rise in potential is what?
मैम
Voltage is rising. हाँ, tell.
एक और कन्वेंशन था ना, जैसे आई आर को प्लस लेने से और ई को पॉजिटिव टू नेगेटिव में प्लस लेने से वही सेम इक्वेशन आता है, तो एग्जाम में वो यूज कर सकते हैं
क्या 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 और एक बार बोलो.
मैम? जैसे ऊपर वाले इक्वेशन में
इधर
जिसमें
इधर दिस वन.
यस मैम, जैसे इधर प्लस ई ले लेंगे और आई आर वाले में प्लस आई आर ले लेंगे तो जस्ट ऑपोजिट हो जाएगा.
हाँ, तुम उधर ऐसे मत करो, तुम लोग पढ़े हो शायद आईसीएसई में उसे था कन्वेंशन ऐसे ही.
तो उल्टा कन्वेंशन था.
हाँ, पता है. तो some books they have or some courses they have taken just opposite. Better you do it. What is the problem? It's I am not telling that you will get a wrong answer.
चलेगा ना कोई
हाँ, चल है सकता है. It's not that you. This is a convention actually we are taking. Okay, it's not that opposite to if you are taking that you will get a wrong answer. You can take that as okay. So got it? All of you sign convention? Understood or not? Tell me. Any
Yes, ma'am.
doubt with the sign convention?
No, ma'am.
No, ma'am.
Okay. So now I will do some. I will tell you some terms. Then we will move to the some problems. All of you have calculator with you? Calculator or all of you are having calculator with you or not? If you don't have calculator, bring calculator and sit. Today we'll do problems. Tomorrow you don't have class?
No, ma'am.
Tomorrow only.
No, ma'am.
Okay. Problem 1. So here I am having 3 registers. 3 registers. 1, this one is 2, this one is 3. Okay. So here you will find out what is the value of here 20 volt I am providing. This is let it is 15 ohm, this is 15 ohm, this is R ohm, this is 10 ohm. You tell me what is the value of R. Find out the value of R. Yes, current is your current here. The current is 1.5 ampere. Don't take much time. These are all basic questions. Just to rephrase whatever you have read it in your 12th, I am giving you. Yes.
No, 6 ohm.
Yes. Very good. Who has done? Tell me. Tell your name. Let me know.
Arya.
Very good. This is 6 ohm. How you have done? Tell me. Let us do with his procedure. Yes. Tell me, Aryan.
Ma'am, first 15 are in parallel, so I've taken the R equivalent.
Yes. What is the R equivalent you have got?
15 by
15 parallel with 15 parallel with R. How much you are getting? Tell me.
15 by 15 R by 2.
15 divided by
15 R by plus 2, sorry.
15 divided by
15 R plus 2.
15 into.
No, ma'am, 15 R.
15 hour.
Oh, sorry.
7.5.
15 R plus 2.
Yes.
Okay.
Then
Then what you have done?
is in the series with 10 ohm.
Yes. Very good.
And then, ma'am, the whole circuit has current going, sorry, resistance is 40 by 3 ohm.
Plus 10 ohm. Whole resistance is
40 by 3.
total resistance.
V by I.
Yes, ma'am, R equals to 20
This
by
is your, how much resistance it is? 40? 40 by 3.
40 by
No,
3.
ma'am. V by I is
Your
No,
V
no,
divided by
40
I
by
is
3.
equal to how much? 20 divided by
40.
1.5. How much it is?
40 by
40 by
40 by
3.
3.
40 by
That's what I was writing, na?
Yes.
40 by.
Then I have equated the.
Okay. Then you have got the value of R. There are different ways you can find it out. Okay. All of you have got it?
Yes,
There are
ma'am.
different ways.
Yes, ma'am.
Now I will give you a question related to current divider rule. Current divider rule. Amish, have you written? Have you done? हाँ? अमित
Yes,
है
ma'am,
या
I'm
कॉलेज
doing
छोड़ दिए?
it. I'm कर रहे हैं, I'm doing.
Okay. You this one you do. Calculator रखो. Whoever is thinking that I will do manually and I will get the answer, manually तुम करो, no issues, but you are not getting any mark for that. एक equation है, suppose the equation is there, and you will solve that equation manually, you are not getting any mark for solving the equation. So better with the help of scientific calculator, put all the coefficients of the equation, you will get all the values of the variables. Okay, if you do not know, you tell me, I will send you a video how to solve the equation directly by using the calculator. Just you have to put all the coefficients of the equation and you will get all the values of the variables. Okay, so this is 25 ampere. This one you take it as 6 ampere. This one is 0.27. This is 0.5 S and this one is 0.25 S. How you do this one? You tell me. How you do this one? First you do it in ohm, then we will go for S. First you do it in ohm. Take all this as ohm. Okay. So this circuit, can I add these two current source? Remember that when voltage sources are connected in series, when voltage source are in series, they are added. Got it? When voltage sources are in series, they are added. When current sources are in parallel, they are added. You know this or not? When current sources are in parallel, they are added. You know this or not?
Yes, ma'am.
Yes. So when current sources are connected in parallel, we can add it. So if I will add 25 ampere with 6 ampere, then what I will get? Tell me. What I will get? 19 ampere I will get, which is flowing upward, because 25 ampere, which is the highest current, that is going upward. Okay, so if I'm taking minus, so 19 ampere is going upward, and this is 0.5 ohm. This one is 0.25 ohm. Another one is, this is what? 0.2 ohm. Now can you apply current divider rule? Tell me. Now application of current divider rule. Tell me. I want all the values of the current. This current I want I1, I want I2. I1 will be equal to how much? Tell. Quick. क्या होगा या नहीं होगा बोलो.
Yes, ma'am.
I-
होगा मैम.
Yes, yes, good. You tell me the formula. Let us not solve.
मैम
You tell me the
I1
formula.
equal to I
It will be
into
19 multiply with, because I know the total
Yes,
current,
ma'am.
19 ampere current now is divided into 3 parts. So when I am finding the current in the first part, then I have to take the second part as the resultant. That means 19 multiply with how much? 0.25 parallel with 0.2 divided by how much? 0.
R1
Sum
plus
of all these three
0.5
results.
plus
Very good.
0.25
0.25
plus 0.2.
Very good. Very, very good. Okay. So now same thing here. If I am finding out I2, it will be 19 multiply with 0.5 parallel with 0.2 divided by how much? 0.5 plus 0.25 plus 0.2. Similarly, I3 will be equal to how much? 19 multiplied with 0.5 parallel with 0.25 divided by how much? 0.5 plus 0.25 plus 0.2. Am I clear to each one of you? Each one of you. See, I am
Yes,
working.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Very good student. You understand quickly. Now come to the third problem. We have to go to another five problems are there. We will do within 20 minutes. Third, here a circuit is there. One ammeter is connected here. This is 15 ohm. This one is 11 ohm. This is 8 ohm. Another battery I am giving you. This is E. This is 11 ohm. This one is 13 ohm. You will, this one shows a voltmeter is connected across a 8 ohm. A voltmeter is connected across a 8 ohm. This shows 20 volt. You tell me what is the current in the ammeter. What is the reading of the ammeter? And what is the battery? Yes, this is also not known. What is the battery? This one. Kind of. Suprasad.
Yes, ma'am.
This one you will tell. Do it.
Yes, ma'am. One second, ma'am. I'm doing the previous one, ma'am. Complete.
Why? Previous one not completed.
Ma'am, I'm finding out the answers.
The answer not required. Answer not. I am telling you one thing. Listen, all of you. If you are writing these three equations, suppose you are using current divider rule. In my process, I am telling you. If you are writing these three equations, 95% mark you will get. Answer if you are using a scientific calculator, then is no question of getting a wrong answer. Okay, no need to calculate it manually at all. All the everything is there in the scientific calculator you are using. You are allowed to use scientific calculator in your exam. So take the advantage of it. उसका जो instructions है उसको रखो properly. A big integration also you can solve. Differentiation you can solve. Equations you can solve. Equation with n variables you can solve. Okay, so all these things you can do it. So these equations, if you are writing, 95% mark. I give very less mark for answer. Steps should be proper. Okay, remember it. Second question, chalo. So Prasad, do the second question. Yes, don't take much time. I have given a easy question. Just you will apply your brain only, nothing else. It's you think that it is difficult, but it is very easy. How do you find out what is the current in the 20 volt is given? Okay, 20 volt is, look at here, 20 volt is given. So how much current is flowing here? Tell me. This is 8 ohm resistance. It is 20 by 8. That is equal to how much? I
10 by 9.
will be equal to 2.5. Yes or no?
Yes, ma'am.
Got it or not, all of you? Now, understood all of you or not?
Yes, ma'am.
Yes, ma'am.
8 ohm is there, voltmeter is connected, it is showing you 20 volt. So that means current in this here it's 2.5 ampere. Okay, so that 2.5 ampere is also flowing in the 11 ohm because both are connected in series. Am I clear to all of you? Okay.
Yes, ma'am.
So now this 2.5 ampere is going here. Now I want the current in the ammeter. What is the current in the ammeter? So this 2.5 ampere current is flowing into two parts. What is the first part? This is the first part and this one is the second part, right?
Yes,
Got
ma'am.
it or not? Because this current is flowing here, another current is flowing here. Two parts are there. So what will be the current in the 11 ohm and what is the current in the 15 plus 13 ohm? Okay. So tell me, I want the current in this ammeter. So I will write down the current in the ammeter will be equal to how much? Tell me. Use current divider rule.
मैम मेरा 0.9 आ रहा है.
0.9 तो नहीं आएगा.
0.705.
705 भी तो नहीं आ रहा है. Okay, tell me the formula. Let us see where you have done the wrong. I ammeter will be equal to how much? Using current divider rule. Use current divider rule. 2.5 multiply with how much? 2.5 multiply with how much? Tell me. I am finding out the current in this direction. This one I want to find out. The current in the ammeter. That means this current is flowing in the ammeter itself. Got it or not? This current is flowing in the ammeter itself. Suppose this is I1 and I2. I want I2. I2 is flowing in the ammeter, right? Got
Yes.
it or not?
Yes, ma'am.
So,
Ma'am, 1.794.
no. How much it is? Tell me. 2.5 multiply with how much?
28 divided by 28 plus 11.
Why 28? I am
11
finding out
divided by
the
28.
11 divided by how much?
28.
11 plus 50.
Plus
39.
30. This much.
39.
0.72.
39.
It is equal to
28.
0.7. Understood or not? This equation only you need to write down. This is nothing difficult. Am I clear to all of you or not? I have used only current divider rule. Understood all of you, or you are feeling difficult in putting current divider rule? I will take when I'm finding the current I2. This I2 current is flowing in 15 ohm as well as 13 ohm. Here nowhere the current I2 is again divided. Okay, so I have two path. One path is I1, another path is this one. Got it or not? So 2.5 multiplied with 11 divided by how much? 11 plus 13 plus 15. That means suppose I have confused you. Suppose I will just drop this one. I will drop this one. Okay, I will tell this as a two resistance I have connected in series. Two resistance I had connected in series. I will write here 15 plus 13 means how much? 28, right? I will write it 28 ohm. Is my circuit wrong? Tell me. Whatever the circuit I had drawn it before, and here is the circuit wrong? Same circuit.
So
Just I have divided. Suppose I would have given this circuit, you would have written, yes, madam, 2.5 into 11 divided by 11 plus 28. You would have written or not? Tell me.
Yes, ma'am.
Yes. Same, just I have divided the resistance only, nothing else. Both are connected in series. Nowhere the current is divided. Here, same current is flowing. Both are connected in series. Am I clear to all of you? Understood?
Yes, ma'am.
I am not listening
Yes,
any
ma'am.
sound from girl student. I expect some girls respond me whether you understood or not.
Yes, ma'am.
Okay.
मैम
Now, tell.
मैम
Tell.
जैसे करंट मैम जैसे करंट अगर सॉरी रेजिस्टेंस अगर डिवाइड हो जाता तो मैम उसमें थोड़ा एक बार बता देंगे क्या, मतलब अलग सर्किट हो जाता तो, जैसे प्रीवियस वन में आप करंट डिवाइडर रूल अप्लाई किए, बोला मैं थोड़ा
देखो यहाँ
कंफ्यूजन
पर नेक्स्ट सुनो, कंफ्यूजन होने की जरूरत नहीं. सी all these circuits are connected in parallel. Different currents are flowing here. In this current is not flowing in here. This current is not flowing here. All the circuits are connected in parallel. So all the currents are different, right? But in this case, what I have done it is, suppose here I would have taken, suppose here I would have taken, how much I have taken? I forgot it. 2.2, na? 0.2. 0.2. Suppose I will to confuse you, I will draw this one, 0.1 ohm and 0.1 ohm to confuse you. But these two resistors are connected in series, right? These two resistors are connected in series. So one current will flow both in 1 ohm, 0.1 ohm as well as in 0.1 ohm. So when a current is divided here, it will take into consideration both the resistance, right? Understood who was asking me? Got it? Same thing I have done. So when the current will be divided, 19 ampere current will be divided into 3 parts. So according to the resistance, all will take the current. Okay? Here both the resistance are connected in series. So accordingly it will take. Similarly, here what I have done it is, here also I have divided 28 ohm resistance to 2 parts. One is 15 ohm, another one is 13 ohm. But both are connected in series. So when a current is flowing, it will take into consideration both the resistance, 15 ohm resistance as well as the 13 ohm. So what is the total resistance? Both are connected in series. What is the total resistance? Total resistance is how much?
We'll add
How much it is? Oh, add.
28.
समझ में?
Yes.
Got it or not?
Yes, ma'am.
So while doing more problems, your concept will be more clear. Don't worry, because in most of the time we'll be using current divider. Okay. Now next question you do. Another simple question I'm giving you using Kirchhoff's current law. This is the circuit. This is the current. Just wait. This is a resistance. This is another resistance. This is another current source. This is 8 ampere current source flowing downward. This is take this as 30 ampere current going upward. Just use Kirchhoff's current law. Application of Kirchhoff's current law only I have given, nothing else. How much current is going downward, outward? You will tell me what is the value of V. V is the potential difference across these 6 ohm. Tell me. थोड़ा थोड़ा मैं तो कंफ्यूज कर रही हूँ, सिंपल को थोड़ा कॉम्प्लिकेटेड करके पूछ रही हूँ.
मैम ये तो क्वेश्चन नंबर 2 के जैसा सेम ही हो गया ना.
नहीं, यहाँ पर V निकालो Find out the value of V.
Yes, ma'am. Yes, ma'am.
Using Kirchhoff's current law. दूसरा कुछ मत यूज करना. Only use Kirchhoff's current law. इतना पढ़े हो Kirchhoff's current law, देखेंगे क्या अप्लाई करें.
कैसा गोल 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 है.
मैम 14.6
14 पढ़ना नहीं, मैं भी सॉल्व नहीं की हूँ. 15.6 वोल्ट नहीं है. मुझे निकालना भी कितना
2.16.
कितना कितना आ रहा है.
2.16.
नहीं, ये भी रॉन्ग.
मैम अप्रोच यही रहेगी ना कि सबसे पहले तो 22 एम्पियर हो गया करंट फ्लोइंग, देन 2 6 4 पैरेलल में, तो उसको करके उधर से रेजिस्टेंस निकालेंगे.
क्यों इतना करोगे? तुमको मैं आई हैव टोल्ड यू ओनली यूज
24 volt. 22 मैम.
who has told 24
24.42.
who has told 24 volt?
हमारे
आर्यन क्या 24 वोल्ट इज द आंसर.
यस मैम. मैम वो ऐसे ही निकाले मैम, पैरेलल में जोड़ दिया रेजिस्टेंस को और फिर
Yes, ma'am. आ रहा है 24.1 आ रहा है.
Yes, ma'am.
अच्छा, okay, very good. There, and you have found it out. I will take simple. I have told you na. I have given this circuit only to apply Kirchhoff's voltage law. No equivalent resistance, nothing. See, a simple. I will arbitrarily take I1 यहाँ से आ रहा है. It is flowing outward. Okay. Then suppose I will take this one. I will take as I2 अंदर जा रहा है. Suppose one current I am taking it as I2. Another one is I3. Two current is flowing out, direction is here like this, and another current is going inside. I will just apply Kirchhoff's current. I have told you to apply Kirchhoff's current law. Just you tell me the equation. What is the equation? Minus I1, then plus 30, then
30
plus I2,
plus
then
I2
minus I3,
minus of I3
minus 8.
of
Is equal
8
to-
ampere.
ये इक्वेशन किसी का डाउट है? मुझे बोलो, किसी का डाउट है इक्वेशन में? Anybody having doubt in this equation? Tell me.
No, ma'am.
No. Now VI is the potential difference across this one plus minus. That means the voltage across these 2 points is V. Am I correct or wrong? Potential difference
Yes,
across
ma'am.
6 ohm,
Yes,
I
ma'am.
have told you, implies the potential difference across these 2 points is V, right?
Yes ma'am.
Got it or not? Okay. So what is the value of I1? Tell me. I1 can I write down? It is V by 2. Correct or not? Correct or not?
Yes ma'am.
I2 can I write down as, because I2 is entering here. Okay. Minus V divided by 4. Minus V divided by 6. Yes or no?
6.
Yes, ma'am. 6,
Got it or
ma'am.
not?
Yes, ma'am.
Very good. I3 is equal to how much? V divided by 4.
P divided by 4.
Yes, ma'am.
Substitute karo, only variable will be V will be 24 volt. Correct or wrong? Tell me.
True.
डिफिकल्ट था क्वेश्चन?
मैम हमने वो रेसिस्टेंट
क्यों रेजिस्टेंस? अरे क्यों रेजिस्टेंस? हाँ कर रहे हो, कर सकते
मैम
हो।
नीचे वाला पॉइंट भी लेके कर सकते हैं ना?
हाँ हाँ, नीचे
हम
वाला
कोई भी
point
point।
ले सकते हैं। हाँ हाँ, ले सकते हैं डिफरेंट वेज।
यस।
ओके, गॉट इट ऑल ऑफ यू? कितना टाइम हो गया? हो गया टाइम। और दो प्रॉब्लम में आई विल सेंड यू इन और अपलोड इन द क्लास। ओनली वन क्वेश्चन आई एम गिविंग यू। Only one question I'm giving you. This question may be complicated, but it looks complicated, not complicated. It looks complicated, but it is very easy. ये सब problems तुमको जितना problems you will do, your brain will be churned. Okay, brain active रहेगा जितना problems तुम करोगे। 3 ओम, तुम लोग तो बोलोगे हम लोग कंप्यूटर साइंस इंजीनियरिंग स्टूडेंट है, हम लोगों को सिर्फ कोडिंग चाहिए। ठीक है, कोडिंग करना, पूरा सेमिस्टर और पूरा कैरियर पड़ा हुआ है। एक सेमिस्टर प्रॉब्लम सॉल्व करके ब्रेन को एक्टिव कर लो। दिस इज 2 ओम। ओके, यू विल फाइंड आउट व्हाट इज द वैल्यू ऑफ V1। V1 कितना है फाइंड आउट। किरचॉफ्स वोल्टेज लॉ है फॉर यू। हाँ हाँ, R2 इज R2। R2 है, R2 का कुछ वैल्यू जस्ट यस, फाइंड द वैल्यू ऑफ V1।
वो R एक ही R1 है।
क्या 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 बोल रहे हो? बोलो।
R है।
हाँ हाँ हाँ, करंट्स में नहीं दी हूँ। I will give the current. This is 16 ampere current is going here. This one is 4 ampere current is going here. हाँ, क्या बोल रहे हो? कोई who was asking something? हाँ, tell. Who was asking? Any doubt in the question?
R है।
ये R है, ये R1 है। R नहीं, R1 करो, ये R2 करो। इसका कुछ वैल्यूज पता नहीं है। You have to find out what is the value of V1.
ओके
ओके मैम।
अभी करें मैम?
अभी करो, 2 बज गया है, 1 मिनट लगेगा। ओनली 1 मिनट, नॉट मोर देन 1 मिनट। किरचॉफ्स वोल्टेज लॉ अप्लाई करो। आई एम गिविंग यू द हिंट। किरचॉफ्स वोल्टेज लॉ अप्लाई करो। पढ़े हो किरचॉफ्स वोल्टेज लॉ? स्टेटमेंट, डोंट रिमेंबर ओनली द स्टेटमेंट, you should know where you are applying, how you are applying. किसका हो गया? Only apply, giving you hint again and again. I'm telling you, apply Kirchhoff's voltage law. Only one equation will solve you the value of V1.
Yes ma'am।
करो। Chetna, are you there?
Yes, ma'am.
Doing?
Yes, ma'am.
Okay. Yes, who has done? Everyone do. Aman, are you doing? Aman Kumar, 852.
Yes ma'am।
Very good. Aryaman?
Yes, ma'am, doing it.
Doing. Shayani Shur, doing.
Yes, ma'am.
Saurin Mukherjee,
Yes, ma'am, doing.
Priyesh is absent. Neil,
Yes, ma'am, doing.
Divash,
Yes, ma'am, doing it.
Anvay,
Yes, ma'am. Doing it.
so much time you are taking doing? See, a simple equation will solve. I will apply, I have told you, just apply Kirchhoff's voltage law. I want V1, I will apply Kirchhoff's voltage law in the circuit. What is my equation? Tell me, I will start from here. So I know the current, I know the sign convention. It will be minus 16 into, I am traveling in clockwise direction. Okay, what is my equation? Look at my board, all of you. What is my equation? Minus 16 multiply with 3 because I am traveling in the same direction as that of the current. Minus 4 into 2. This is a battery source. It is plus minus. So plus 40 minus V1 is equal to 0. Tell me, why so much time you have taken?
मैम हमने तीन इक्वेशन बना लिया इसीलिए
वही मैम हम भी वही कर रहे
इक्वेशन बताए क्यों 3 इक्वेशन?
Yes, ma'am, 3 equation.
क्यों 3 इक्वेशन क्यों बनाए तुम?
मैम 10 वाला का
मैम 10 वाला भी तो
10 वाला का भी बना लिया।
10 वाला का भी बना लिए, क्यों इतना इक्वेशन? मुझे तो V1 चाहिए क्वेश्चन में।
यस मैम
हाँ?
Yes, ma'am.
I want V1.
मैम
10 वाला में इक्वेशन तुम क्यों निकाले? Why?
मैम
हाँ, बोलो।
मैम व्हाट अबाउट द R1? इट इज आल्सो इन द सर्किट।
हाँ, R1 I don't have, I don't, after I get the value of R1, when, in order to find out, my question is to find out the value of V1.
ओनली द V1 यस मैम
V1 का मुझे पता होना चाहिए। R1 R2 का मेरे में इम्पोर्टेंस ही नहीं है। मुझे क्यों चाहिए R1 और R2 के वैल्यू? समझ में है?
माइनस 16 आ जाएगा।
हाँ, question C, I told you ना initially, question will look complicated, but it
Yes,
will.
ma'am, minus 16 आ रहा है.
मैम बट उसमें भी तो जाएगा ना करंट?
किस में जाएगा?
R1 R2 वाले में।
हाँ, R1 R2 में करंट जाएगा, कौन मना कर रहा है? R1 R2 में कौन जा रहा है तो? करंट
Ma'am,
जाएगा।
Yes, ma'am.
While solving, see, करंट जाएगा, यहाँ पर क्या दिया हुआ है क्वेश्चन में? See, here I have given this is plus minus 40 volt. This is minus plus, this one is voltage across R1 is V1. Okay, so I have just applied Kirchhoff's voltage law in the outer loop because I know the current in the 3 ohm, I know the current in the 2 ohm. I am just applying the Kirchhoff's voltage law in the outer loop because Kirchhoff's voltage law you can apply to any
Yes,
closed circuit.
Yes, ma'am. In the outer loop, R1 is there. No, so we have to include R1 because
Huh?
current is
I-
also
I
flowing
have-
through R1.
See, in order to get the value of, in order to know the potential difference across R1, I need the current, but I don't have any information about the current, right? So, but V1 is, I know V1 is an unknown, which is the potential difference across R1. So, I will take V1, directly I will get V1. V1 will be equal to how much? Whatever
Minus
the
16.
value. Huh.
Minus 16.
In my question only V1 is, V1 has been asked,
Ma'am, minus 16.
minus 16.
अरे वो साइन कन्वेंशन
नहीं, minus 16.
Understood or not? Got it or not?
Yes,
In
ma'am.
not-
Somehow
in
I'm
my-
not getting it. I don't know why.
Okay, I'm telling
How
you.
can we
Ma'am, वो last
skip it like
R1
मैम
R1?
R1 को क्यों
How can
एक्सक्लूड
we
Ma'am,
separate
R1 भी तो
R1?
मैम लेना होता है
ना?
ना.
वो तो
सुनो
लेना ही
सुनो
पड़ेगा।
सुनो सुनो R1 अच्छा तुम इधर ही कंफ्यूज हो गए. ओके, R1 तुमको लेना पड़ेगा. सपोज द करंट इज इक्वल टू वट एवर मे बी द करंट, बिकॉज आई डोंट हैव एनी इंफॉर्मेशन. I into R1 is equal to V1 itself, right? Understood or not?
Yes, ma'am.
Because
Yes, ma'am.
I have the potential difference across R1, it is given as V1. V1 is not known to me, that is a different, but it has, when V1 is taking, when V1 you are taking, that is equal to how much? I into R1, right?
Yes, ma'am.
So you are taking R1. Someone was asking me question, I am not getting. I am particularly telling you. Who was telling? Are
Yes,
you
ma'am.
getting now? Are you getting
Yes,
now?
ma'am. Yes, ma'am. Now I've got.
So R1, it has given the potential difference across R1 as a B1. So obviously it has taken the potential difference across R1 and it has taken that as a variable, that is B1. Understood?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So where you don't think that when B1 is written, it is not taking into consideration. B1 is equal to whatever the current is flowing. That is, suppose I am telling you here, it would have 4 into 2 ohm. It would have not written. It would have taken a voltage source here. Here a voltage source it would have taken. You would have taken 8 volt. Okay, this is 8 volt. You would have taken 8 volt. Okay, similarly, it has taken the potential difference across R1 as it has taken V1 and it has asked V1. Understood now? I think I am clear now.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so I told you now the circuit is complicated. You will look like complicated, but it is easy. Okay, I have taken the attendance. You can leave, all of you.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you.
Thank you, teacher.
Thank you, ma'am.
Thank you, bye.